All right, thank you so much. Thanks to our host, Embedded Computing Design. I really like this opportunity to even reach out to more of the real developers that are going to use our kits. So again, I'm Dave Garrett, the VP of Technology and Innovation at Synaptics. And so my group spans all of the users that are going to use the boards, the teams that develop the neural accelerators inside these chips. We actually build all of the Wi-Fi modules that go on here and all of the components that build into a developer kit. So what we're showing you today is our Machina kits. It's a Linux Yocto-based board, and it has substantial neural compute on there. So not only do we have 8 TOPS of compute power, it boots Linux, it's easy to get into, and developers.synaptics.com gives you all the tools to get right into this board and get going. So we did a really neat tutorial session yesterday where we had 50 people. We sold the boards along with the kits, cameras, and microphones. All the tutorials within an hour, you'll be into this board, logged into it, running Python and running body analytics models from Hugging Face right on the board, running the object detection frameworks. Those all come open source. The tutorials are easy. The Python dev kit allows you to get in there. We support the VS Code plugin so you can get in and really code and do your own applications on this board. So it's neat, in that very powerful Linux processor on board, along with our NPUs, it's got the interfaces for cameras, it's got the display drivers, it's got all the USB peripherals so you can get any of the devices into this device. And that's really what we're looking for at the edge. How do you compute at the edge? You need to talk to all of the paradigms of vision, hearing, sensing, light, ambient sensors. Any of those sensors can get into our device. If you look at it, it's a modular system. We have a family of parts. So we have the 1680, which is our highest performance NPU. We have the SL1640, a different processor. It's in the mid-range. And then the 1620, the lowest end Linux processor that still gives you substantial compute. You know, Synaptics is a multi-threat company. So not only are we a processor company now, so we're building smart MCUs, we're building smart MPUs, we also have wireless. So if on the back side of this, we have our wireless modules on there. So not only are you into the device, we have the wireless connectivity and the Bluetooth drivers already baked in. So these come with the kits that you buy. Go to developers.synaptics.com. You can actually buy a kit. They're available today at Mouser. They'll ship right to your home. We've put the material online. I promise you within an hour, you'll be running all of these neural networks. And then what you can do is, what we want you to do is hack this kit. I want you to go in, run a neural network, do a body detection, and then see what you can do with that in your home. See if you can create new applications. And that's how products get created. So, again, there's a famous story in the book Freakonomics about, taking a class, and they took a pottery class and they divided it in half. They said half the class is graded on the best pottery piece that they made. The other half of the class was graded on the pounds of pottery that they made. Who actually had the best piece at the end of that class? The pounds of clay or the best one product? Nope. The pounds of clay. The people that actually put mileage on a platform, that do as many things as possible and learn, or actually have the best outcomes. So that's what we want you to do to this board. I want you to go play with it. Go find out what you can learn, see how it works, go build on it, and you're going to create the next product out of that platform. So amazing kit. We've announced this today. It's ready to go. We've also, at the show, we've announced our smart MCU kits. So the Machina is our Linux-based platform. In the coming months, at the same portal, you're going to see our RDKs. So similar platform, but this is a device that actually can run vision at 1 milliwatt, 10 milliwatts when it sees something substantial, and 100 milliwatt neural processing to really grind out the gears of an embedded application. And so that, this is the big iron. We have the small iron that'll let you do really amazing things at the edge as well. So that's our play, is to have all these RDKs, these reference design kits that you can go build. If you actually look at the dev board, there's actually modules. So we have providers that are building the SOMs, the system on a little dev kit that can actually bolt into real products too. So this is the platform that gives you all the interfaces, but you can actually take this and funnel it down to exactly what you need to do. And so with that, I guess I'll open up to questions. Would love to have your thoughts, questions, and let me know how I can help.
Dave, what are we talking about from a performance perspective of the SL versus the SL?
Yeah. So the SL series, the Linux block, multi-processor, A-class ARM cores on there, and in the highest end, we have 8 TOPS neural accelerator on there. And so without an ounce of the processor compute, we can running powerful vision networks on this device. The 1640, it's around the 2 TOPS range, so we've cut the size down. We have a cost point, which is in the middle. 2 TOPS is still an enormous amount of compute at the edge. And then the 1620 really is the low end, the embedded processor. We do a lot of multimedia. We can still have a display driver on that part.
Software open?
Open source. That is one of the key tenets of us. I don't know if you saw, we just had an announcement with Google. We are working with the Google research team to put together the open source compilers for ML networks. So that engagement that we're working on is making sure that any network, any device can come into our device and work. So MLIR is the newest compiler format that your models, no matter where you develop, PyTorch, TensorFlow, wherever you want to work on things, Onyx models can come into our devices. So we're super excited about that, the validation of our strategy. So it's not a proprietary lock-in, it's the best parts of open source, meaning we're going to open up that compiler, you'll actually see the nuts and bolts of it, and you can just be a consumer to map your networks to all our devices.
Where do you buy them?
Mouser. Buy a dev kit, Synaptics, developer.synaptics.com. They give you a direct link right at the top of the page. Mouser has them, you can get them delivered right now. They're in stock, ready to go. Yeah.
As for the AIO, do you have just like the USB and you have more
So USB, it's got USB-C,
yeah.
HDMI. It's got the standard 50-pin, Raspberry Pi compliant header. So all of those dev boards actually can bolt in, and you can take advantage.
I2C?
Yeah, I2C. It's got all the GPIOs, I2S. It's got the PDM microphone support, and then essentially anything on that header, which is common across many platforms.
Do you have any hands-on training? So there's the build your own embedded systems classes, but any other hands-on training at shows or that Synaptics offers?
Yeah, I mean, that's neat. We've done this now twice for Embedded World. So we had the developer class, hands-on, with our experts walking around and helping you do that training. What we found is we were honing the message that training is available to anybody online. So we've got the recordings. Essentially there's a developer portal where you can post questions. So what I encourage you, I think it's pretty self-explanatory. You should easily get through our training. If you run into any trouble, file tickets. We make sure our team addresses that as quick as we possibly can. And I'm sure we'll be here next year again doing the same thing. It was a huge success. It put people in the platform. Yeah, go. We do. So our booth is over in 4A. So we have 6 different demos running around the Astra platform. We have some really cool computer vision. There's a pill sorting application where there's a conveyor belt running pills of different colors. The Astra board is running computer vision to identify the ones that don't match out of that. And so that's a real application where someone's using our board to do an industrial sorting with computer vision. We've got demos of our voice assistant. So on this, we can actually use a microphone, listen to your like a question and answer, and return a database of responses. So that's using modern sentence transformers, speech to text. We have a text to speech model that all runs on this platform. So come by 4A, you'll see them. There's some really neat demos. Good question. Yeah.
You said that the environment would be open source. Is it already available or it's coming?
No, okay, this kit, the Machina, it's already up on GitHub. The developer kits are already there. You can build Yocta. You can actually modify it if you need to. We've got pre-built images and the instructions if you want to build your own custom applications. Yeah. Wow, these are good questions. Actually, I like that. Okay, well, I think that's it. Thank you so much.
Yeah, thank you so much, Dave. Let's hear a quick round of applause. That was fantastic. Thank you.
Yeah, there we go.
Next for that was the main feature. That was the main event right there.